density of fluid. Gravity is a factor. Means would mean that in no gravity there will be no buoyancy, but I've never seen an experiment like this. And then this is the volume of the solid, which is inside water. Okay, remember the drawing I just erased. Okay. So if I go back to here to my equation, I can get other information. This is the basic one, right? This is the buoyancy force. I can get more information from this equation. Let me get what I can get. Let me see what I can get. So if I check the beginning and the end, I get mfg equal rho f vsg. Okay, so g is constant on both sides. I can get that the volume of the solid is equal to the mass of displaced fluid divided by the density of the fluid. This is how it's pretty important. You know why? Because this is the way to calculate the density of an irregular solid. Okay. So now we're concerned about the density of a solid. Remember that I talked about bone yesterday? So how can I calculate the density of a solid? I can do it if I know its mass, which is pretty easy, as the solid. The density of a solid, the S of solid is the mass of the solid divided by the volume of the solid. The mass of the solid is pretty easy. If you use a scale, you can measure it. MS with the scale, just stir it, put the solid, and that will be MS. Solid mass. But the volume is complicated. If it's a square or a sphere, you can get it geometrically. But what about the volume of the human body? It's not easy. Here you have a way to calculate the volume of any solid, no matter the shape. Okay, we need to put the solid underwater and measure the mass of displaced fluid. To do this, the easiest way is to hang it from a string, so the weight is compensated. So you get it from the equation, get it out from the equation. You put the solid, can be like a human body, okay? So and the idea is that you tear with a certain amount of liquid, doesn't matter which one. You put it into a scale, right? And you set to 0. Third. Then you hang the solid from a string and you enter just the minimum amount of string, so it is not confused with a part of the body, right? And put it inside. So what you're going to measure is exactly the empirical value of the mass of displaced fluid. And then the density of the fluid, if you use water, the density of the fluid, you can get it because the density of water has been measured before. You measure the temperature, and then there are tables that tell you the density. So MF, you measure it by what is called weight in water, the mass of displaced fluid, is the weight in water. Okay, so it means that you get a liquid, put it into a scale and you tell, and then you hang the solid from a string to balance the weight and pour inside the liquid, with the minimum string possible and not touching the walls not to affect the measurement. And then you will get the mass of displaced fluid directly from the reading of the scale. Okay, called weight in water. So, from this experimental, and this is known because you know the temperature, and then you use water, and that's it, pure water. You can calculate the volume, and then you can get the density. This is used for athletes when the trainers want to know exactly the percentage of, more accurately, the the fat content in their bodies, because fat is less dense than water. So the way to know is by measuring the density of the body. Then with the density, I don't know which is the relation, because you need a model for the body, for the bones and stuff. The idea is that the more fat you have, the less dense you become, because if you have pure muscle is compacted. If actin and myosin is compacted fibers, whereas fat is just triglycerides that they're not compacted, so they are less dense. Okay. And then what's the idea behind all this? This procedure can be used to measure the density of any solid, or if you know the volume of the solid, you can, okay, so here you can know the density of the fluid. You have one, you can get the other. The clear is that the mass of the solid you measure with a scale. Okay, so if you know the density of the fluid, you calculate MF and calculate the density. But if you know VS, you calculate MF and get the density. So it's like one you get one and know the other. This is also used to calculate apply to potatoes, for instance. Can you imagine that? Yeah, but the quality of potatoes is measured using two parameters. One is the water content, how much water do they have, and the other how much sugar. The water content is measured by considering the density, and then the density is related empirically to the water content. Okay, because it's kind of really more or less constant, and it tells you it depends on the variety and the user wanted to use. So, but to give. So, what's the idea? So, let's see. Let's see if I remember. Okay. So the basic quantity in quality control is specific gravity. Specific gravity is the ratio of the density of the solid divided by the density of the fluid. The density of the fluid is going to be the density of water. Okay? Density of fluid, which is water. Specific gravity. Why do we do this? Because with that we avoid getting an absolute value of density, which is not really interested. Okay. So, because the density of we can use it with any fluid. You don't need pure water. Let me get what I have here. Density of the solid divided density of the fluid. Density of the solid, yeah, there. We combine these two equations. Density of the solid is going to be mass of the solid divided by volume of the solid, right? And then the volume of the solid is going to be ms vs. Vs is mf rho f. Okay, yes, by combining these two equations, substitute